Okay, so let's do that. We're going to multiply, now this has to be both sides of the equation, by 3 on the top, and by 2 on the bottom. So then our new system is 6x plus 9y equals 15, and negative 6x plus 10y equals 42. So these are opposite coefficients, so I'm going to add these two equations together. And then what's 6x plus negative 6x? 0. What's 9y plus 10y? 19y. And 15 plus 42 is 57. All right, so let's divide both sides by 19 and see what we get for y. Three. Making sense so far? Okay, so now the same way that we did before, we have to go back and find x. And you can use any of the equations you want to find x. Unfortunately, like substitution, it would already be alone. One of the variables would be isolated, so it's a little, just one extra step. But the process of elimination, I think, is actually a little easier than substitution. I'm going to do the top one. So I'm going to write 2x plus 3 times, in place of y, I'm going to put my solution, which was 3, equals 5. All right, would you solve that, please? Okay, so you should have gotten x equals negative 2, right? And so this intersects at negative 2, comma 3. So that would be your solution. Okay, so if we were to graph these two lines, that's where they would meet. So this would be something where there was an intersection point. That's one way that a linear system can look. What happened on your assignment yesterday? Remember we got that statement, like no solution? And so let's talk about that type of thing. Okay, so this is good practice to decide what to multiply by. What would we multiply maybe the top equation by to eliminate the x? Negative 3, because I'd have a negative 3x plus 3x then. You could do y's as well, but you're going to see it's going to be the same thing, because if I wanted to get a 12, wouldn't I multiply by negative 3? In this case, only because there's no solution, but you can eliminate the x's or the y's. When I multiply the top by negative 3, this is what I get. The bottom stays the same. So what happens then? You get 0 plus 0 equals 10. Okay? And so you get a statement that's not true. It's not ever true. And so what if I were to graph these two lines, they would be parallel lines. So we don't leave this like this, we actually write that we understand what this means, that there is no solution to the system. Okay, so but I want to point out to you that the result of that was there were no variables, but that was a statement that wasn't true, because coinciding lines look similar in that you get the variables to drop out, but then something different happens. Alright, so a coinciding line or coincident system would mean maybe you can't identify it right away because the lines are rearranged, but if you were to graph them, you would get the same line. We call it coincident line. So let me just show you what something like that might look like. Let's say I had 4x minus 5y equals 2. And then negative 8x plus 10y equals negative 4. Alright, so let's say I said, hey, why don't you eliminate for the y's this time, okay? So we have negative 5y and it's plus 10y. What would we multiply by? Yep, let's multiply the top equation by 2. So we get 8x minus 10y equals 4. And then negative 8x plus 10y equals negative. And you add them. Oh, and we get this familiar thing here, but this time I get 0 equals 0. Or maybe you'll get something like 5 equals 5, or negative 7 equals negative 7. This statement is true, and basically what this means is you could put anything in for x and y, and then it would give you a true statement. So if this is always true, that's when we call it a coincident line. So I like to graph a coincident line by, I'll just use 2 colors. So you would graph one, and then when you would go to graph the other, it would be right on top of that one. And so how many points of intersection do those 2 lines have? Yeah, we can't describe it, we can't say how many. There's an infinite number because these arrows go forever. And so we don't write infinity, okay? We just write an infinite number of solutions. Infinite number of solutions. Okay.